Hello everyone, welcome back for lecture series. We previous lecture we have seen the design of a flat belt drive. In this lecture we will discuss about the design of V belt drive as well as chain drive. Okay, so let's take a example or numerical related to design of V belt drive. A standard V belt drive or belt is to be used to transmit 10 kilowatt power from an electrical motor running at 2880 rpm to a reciprocating compressor expect to run at 800 rpm. So the input speed is 2880 rpm and output speed is 800 rpm. Select a V belt and recommend a center distance. Use the following data, that is a recommended range of belt speed, that is 20 meter per second to 25 meter per second. Load correction factor is 1.0. Okay, so first of all note down the given parameters. P is equal to 10 kilowatt, uh, or you can say speed of smaller pulley, small n is equal to 2880 rpm. Speed of larger pulley, capital N is equal to 800 rpm. So we just simply draw a specific simple arrangement of V belt drive as it is user V belt drive as normally used for a shorter distance. For example, you might be seen such V belt drive in a lathe machine and which we work in a workshop. So here at that there or shop floor you can see such type of V belt drive. Also you can see V belt drive in previous what you can say tape recorders or where the shorter distance but larger than the distance required for a gear drive. Okay, where you can use a V belt drive rather than the flat belt drive. So now first step, design of or you can say calculation of design power. PD is equal to FA into P, that is 1.0 into 10. The design power is equal to 10 kilowatt. Next one, the selection of appropriate V belt cross section. Okay, to select appropriate V belt cross section, refer PAG page number 7.58. Okay, here it is shown. So appropriate cross section which we can find out based on the usual or we can say design load. As we our design load is range is 10 kilowatt and which is in between 2 kilowatt to 15 kilowatt. Okay, so that's why we are selecting the cross section area of V belt drive is B. Then recommended pulley diameter is 125, width 17 mm, nominal thickness 11 mm, and weight per meter is 0.189. The cross section which we have seen over here. Okay, so it is a standard section for 40-degree V shape. So note down all the standard parameter values. Okay, so we have selected P section. Calculating the pulley diameter. The assuming belt velocity is up to the given condition is that the recommended belt velocity is 20 meters second, 20 meters per second to 25 meter per second. We are assuming 21 meter per second. Okay, so based on the velocity you can find out the diameter. D is equal to 140 mm. Okay, standard one, and the capital D is equal to 504 mm. Okay, so these values are calculated values. Now referring with the standard values, okay, what we get, the small d standard nearest standard value is 140 mm, and for capital D the nearest standard value is 500 mm. Okay, now we have to calculate actual velocity. based on the standard velocity. Okay, so putting the diameter and calculating the values, what we get, the actual velocity which we get is 21.11 meter per second. Next step is to calculate the approximate center distance between these two pulleys. So capital C, or you can say C is equal to D plus D, that is capital diameter, pulley diameter plus a small pulley diameter, divided by addition of both, that can be a approximate center distance, that we get is 640 mm. Next one, the approximate pitch length and the inside length. So pitch length L is equal to 2C plus pi by 2 D plus D plus D minus D divided bracket square into 4C, which is shown in PSG page number 7.61. Okay, here the equation is given. So by referring this equation, you can calculate the values. Okay. So putting the value of capital D, small d, what we get? We get the total length which we have calculated is equal to 2335.93 mm. Now the inside length, because if you consider the outside and inside length, there is quite a difference. Okay, so that's why the inside length is equal to total length minus delta. Delta is a correction factor which we have considered for different types, that is for A it is 36, B for 43, and for C it is a 56. Okay, so the pitch length that is L minus delta, what we get, the length inside is 2292.93 mm. Now we have to select a exact inside length and the pitch length. Okay, as we have already pitch length, that is a 43. Now we have to select exact length. Okay, so for that we are referring PSG. Okay, in PSG 7.59. Okay, so look at here, the nearest value, our value is 2292. Okay, so here what we seen, it is 2286, and after that it is 2400, which is not acceptable. So that's why we have to select this value, that is 2286. So exact value of the inside length is 2286, and the correction factor for this is equal to 0.1. 1.0. Okay, so similarly you can calculate the other values also. So here cross section area is also given, that is 2329. Okay, so just note it down, this value, so that this value we have already selected. Okay, next one, calculating the exact center distance. So calculating the exact center distance, we can use equation from PSG 6.71. Oh, here the distance is, equation is given. C is equal to a plus square root of a square minus b, where a is the L by 4 minus pi d plus d divided by 8, and b is equal to d minus d bracket square divided by 8. Okay, so putting all the values, what we get, the the value of a is equal to 330.922, value of b is equal to 16,200. So, and value of C, that is the exact center distance, that is 636.39 mm. Next one, power rating kilowatt for selecting the V build from PSG page number 7.64. What for a diameter of 140. 1 minute. So selecting the power rating. PSG page number 7.64 for the rating for V build. We have to select a cross section area, that is 6. Okay, build speed which we have calculated is a 21 point something, so we have selected 21. So here this one we have selected. Then we have to find out the what you can say, the now we have to select a particular equivalent diameter. Okay, so our diameter is 140, so 140 over here. Sorry, I will draw it so you can betterly understand. Okay, so here the value of what you can say, uh, diameter, pitch diameter, which is 140. So what we get, the exact value is equal to, or you can say equivalent power rating kilowatt is equal to 3.75, that is this one value, 3.75 kilowatt. Okay, that power rating we have selected. Okay. Now next one, calculating the arc of contact, that is theta, that is 2 into cos inverse of d by c, d by d divided by 2c, referring PhD page number 6.8. What we get, the arc of contact is equal to 147.13 degree. Now next one, we have to calculate the correction factor for arc of contact. As from referring PhD page number 7.68, okay, here the equations are given. Arc of contact, that is a 2 cos inverse d minus d divided by 2c. Okay, so putting all the values, what we get, the angle is 147.13. okay, if I look at here, there are two values, that is a 145 and 148. So again we have to use a interpolation method to calculate the exact correction factor. Okay, so using the linear interpolation, what we get, the value of FD is 0.9171. Okay, now next one, to find out the belt length correction factor, referring PhD page number 7.59 for section B and inside length 2286, the correction factor is 1, which we have already selected. Okay, then next one, modified power rating. Modified power rating, KW modified is equal to the power rating which we have selected based on the diameter and the belt speed, that is 3.75 multiplied by FD into FC. So what we get, the modified power rating is equal to 3.4391 kilowatt. Now next one, calculating the number of belts. So Z is equal to design power divided by modified power rating at the belt, referring PhD page number 7.70. So PD divided by KW modified, that is a modified power rating, 10 divided by 3.4391. So what we get, number of belts Z is equal to 2.9, which is nothing but integerly the integer value of that, or you can say equivalent value, that is 3. So the number of belts we can use for V belt drive is 3. Okay, so here I have noted down some important parameter which we have calculated. So belt section that we have selected is a B section. Number of belts are 3. Pitch length 2329 mm. Inside length 2286 mm. Diameter of smaller pulley 140 mm. Diameter of larger pulley 500 mm. And the center distance is 636.39 mm. Okay, so see, with the similar procedure you can design a V belt drive. Okay, now next we will see the a numerical on chain drive. A chain drive is to be designed to transmit 5 kilowatt power from an electrical motor running at 1000 rpm to a machine running at 500 rpm. So motor is running, that is the input speed is 1000 rpm and the output speed is a 500 rpm. The service condition involves light shock. What we have to determine? Select a standard roller chain, determine the pitch circle diameter of driving and driven sprockets. Third one, determine the length of chain. Fourth one, specify the correct center distance between the axis of sprockets. And last one, calculate the percentage speed variation. Okay, so first one, select the chain. So number of teeth we are selecting on the driving sprocket is 17. Okay, so equation is given n small n divided by capital n1 divided by n2 is equal to z2 divided by z1. That is, we can say a speed ratio, or you can say transmission ratio, referring page number 7.74. What we get? N1 is equal to 1000, N2 is equal to 500, Z1 is equal to 17. So Z2 is equal to 34 as the transmission ratio is 2. Now, next one, calculating the service factor. Referring page number 7.76. Okay, the equation for service factor is given. At the load factor, first one, Ks is equal to K1 plus K1 into K2 into K2 into K3 into K4 into K5 into K6. So these are the multiple factors which are dependent on service factor. So K1 is nothing but a load factor. Load factor for variable load, or we can say a small variation that we have considered. Sorry, we in our application it is a mild load, or you can say light load. So we are considering is a constant load. K1 is equal to 1.0. Second factor, the factor for distance regulation, K2. We have considered it is a fixed distance. So K2 is equal to 1.25. The factor for center distance of sprockets, normally the range of A, that is center distance, is equal to 30 to 50 T, number of links. Okay, so we have considered this one, and the value of K3 is equal to 1. Next one, the factor for position of sprockets. Okay, normally these sprockets are horizontal, so that's why value of K4 is equal to 1, and the angle of inclination up to the 60 degree. Next one, the lubrication factor. We have considered drop lubrication, which we are using. That's why the value of K5 is equal to 1. And last one, the rating factor. In rating factor, we have considered a single shift and 8 hours per day working condition. If it is changes, the value of KD factor, K6 factor get changes. So the value of service factor is 1.25. Now design power, PD is equal to Ks into P, that is 6.25. Now if we look at the given parameters, we don't have any value. Okay, so if we have a braking power, we can directly go through select a proper what you can say standard chain number, or you can say chain designation. So in this case, I'm going to select a chain designation approximately, or you can say randomly. I'm going to select the chain number, and based on that, the I'm continuing the design. Okay, so referring PHP page number 7.72, or you can go with the 7.71 also. So here the data is given. If you consider a single uh, simplex where the number of chains are 1, so here the value, if you look at the designation 04-1, so 04 is a ISO designation and -1 is nothing but it's a number of chains, that is a simplex, duplex or triplex. If there is a digit 1, it is a simplex. If there is a digit 2, then it's a duplex, and if there is a digit number 3, then it is triplex chain. Okay, so I'm selecting a simple simplex chain RAM, okay, but having a greater breaking load so that it can withstand with the proper, or we can say withstand with the higher load condition. So I'm going to select ISO designation 10A-1 and roll-on designation is R50. Pitch is equal to 15.875. Roller diameter is 10.16 mm. Width between inner plates are 9.55 mm. Pin body diameter is 5.08 mm. Plate depth is 15.05 mm. Overall over joint maximum area is 25.90 mm, and the bearing area is equal to 0.7 centimeter square. The weight per meter in kgf is 1.01 and the breaking load per minute, breaking load in form of kgf is 2220 kgf. Okay, so this is the basic information whenever you chosen any type of chain. Okay, so generally the chain is selected based on the break strength. So here I have just note down the required in data. Next one, calculating the pitch diameter. So referring PhD page number 7.78, the pitch diameter of smaller driven sprocket DI is equal to pitch divided by sine of 180 degree divided by Z1. So it is what we get. So D1 as Z1 is equal to 17 and pitch is equal to 15.875. The or you can say smaller diameter of sprocket D1 is equal to 86.394 mm. Then similarly you can calculate the diameter for largest sprocket. Instead of Z1 you can just use the value of Z2, that is number of teeth on sprocket, largest sprocket. So dt is equal to pitch divided by sine of 180 divided by Z2. So d2 is equal to 172.05 mm. Number of links and the length of chain. Considering approximate center distance, it is here the center distance is denoted by small a, which is equal to 40p. Referring PhD page number 7.74, there is given the range in between 30 to 50, or you can say center distance is equal to 30 to 50 of pitch. Okay, so here we have considered the mid one, 40p, 40 into p, that is a relation. So approximate value of center distance is equal to 635 mm. Now number of links, referring PhD page number 7.75, LP is equal to twice of AP. Just look at the PhD page so that you can betterly understood. Okay, here look at the empirical relations or given the center distance or optimum center distance A is equal to 30 to 50 P, where P is the pitch of chain. Okay, now to calculate the length, L is equal to LP is equal to A twice of AP plus Z1 plus Z2 divided by 2 plus Z2 minus Z1 divided by 2 pi bracket square divided by AP. How we can calculate AP? AP is equal to A0, that is the initial assumed center distance divided by pitch. Okay, so this way you can calculate it, the all the values. Okay, so here we have calculated all the values, and what we get, a value of AP, that is a pitch divided by approximate center distance, that is 0.025. So length, putting all the values of AP, Z1, Z2, what we get, the LP is equal to 105.68, which are nothing but equivalent to 106. So total number of links which are used are 106. Now the exact length of the chain, L is equal to LP into pitch. So the length is equal to 1682.75 mm. Now final center distance corrected to even number of pitches. Okay, which is given in a PSG page number 7.75. Here the final center distance corrected to the even number of pitch is equal to E plus E square minus 8m divided by 4 into P. How we can calculate E? E is equal to LP minus Z1 plus Z2 by 2. M is equal to Z2 minus Z1 by 2 pi bracket square. So similarly, you can find out, you can calculate the value of M, or you can assume a standard value from PAG page number 7.76. Okay, as we have value of Z2 and Z1, we can go for calculation. Okay, so here we have calculated the value of E as well as M. So value of E I get is 80.5 and value of M is equal to 7.320. So putting all the values, what we get, the value of A, that is a corrected center distance, A is equal to 637.52 mm. Now percent speed variation, that equation, pi by z1 into bracket 1 minus cos of 180 divided by z1 divided by sine of 180 divided by z1 into 100. So you get all the, putting all the values, what we get, the speed variation is equal to 1.71%. Okay, so this is the some basic design of chain wheel drive. I hope you have understood this design. If you have any question, you can feel free to anytime contact with me. You can mail or you can WhatsApp your queries anytime. Okay, so refer PhD details which I have mentioned in the description box, as well as the notes which is given in a description box. Okay, the link required for that. Okay, thank you very much for joining this one.